Hello everyone and welcome back to Just Finish Coding. I'm Sriram and this video is part 7 of the color switch series which we're making on Scratch 3. By the end of this video you will have both the stars and the color switchers set up in your game. These objects will be necessary to do things like increasing the score more precisely, changing the ball's color, etc. Let's start by going into the star sprite and into its variables category. Let's create the first variable called y for the sprite only. Then let's create star item number for all sprites. Just like for the other sprites, the variables which are set for the sprite only will be represented by lowercase letters, while the variables set up for all sprites will be all in uppercase. We can create another variable number of stars for all sprites, then current star obstacle for all sprites, then star object distance for all sprites, and finally clone for the sprite only. Alright, now we can hide all of the variables and set up our first event. When the sprite receives the thumbnail message, we can hide it. This will also apply to all of the existing clones. The next event will be a when I receive init. Here we can first delete all of our existing clones the usual way with our repeat and then begin setting up the variables. Before I proceed, I will explain what each of these variables is going to do. The y variable of each clone will store the height at which the clone is located from the origin. The star item number, just like the obstacle item number which we made in the obstacle sprite, is a counter that will go through the level for determining where exactly a new star clone would be located. The number of stars variable will store the total number of star clones that were created from the start of the game. The current star obstacle is going to store the obstacle inside which the new star clone will be generated. If we wanted to generate a new star inside an obstacle such as right here, the current star obstacle is going to be the item number of the obstacle in question. In this case, it is going to be item number of the small circle, which is 11. The star object distance variable is going to calculate the distance of vacant space before we create a new star. In other words, it is the object distance of the specific object in question. We have defined the object distances in the obstacle sprite and we can simply take the values from there to make it simpler. Finally, the clone variable will store whether the object in question is a clone or not. So, getting back into our code, we can start by setting y to 0, clone to no, star item number to -1, and number of stars to 0. We can hide the sprite as well. At this point, we can code in the properties of the new clone that we'll create and then actually create it. So right after we create the clone, we need to move on to the next obstacle in our level list. So what we need to do is thus change star item number by 2. We've just created a new star, so it should be no-brainer to change number of stars by 1. We have to move up on the y-axis and decide a specific point to create a clone, and this will depend on the particular obstacle. So what we can do is create this block called calc distance. Add in an input and make sure you have the run without screen refresh ticked. We can fill out this function later. At this point, it's just important to know that the object's additional distance will be stored in star object distance. We can store the necessary input in the current star obstacle variable, set it to join star item number mod 256 of level and letter star item number +1 mod 256 of level. This is very similar and basically the same thing which we did for the obstacle item number in the obstacle sprite. We can simply put in this variable in the input of the calc distance function. Next, change y by 60 plus star object distance. I will explain the reason for this later, just put in the code blocks for now. Create the clone and then change y by star object distance once again. Now, we will be controlling the clone using the clone variable and it is therefore important that they are differentiated from the sprite itself. So add in when I start as a clone and set the clone variable to yes. We will be creating clones of the star as the player moves up the obstacles. So rather than copy pasting the code that we have in our init message every single time, it's much more efficient to just create another block for it. So I will call this create clone. We can duplicate all of the code after the hide from the init and just change one of the blocks. Instead of changing y by 60 plus star object distance, you can change it by 120 plus star object distance. At first, this may seem very strange and bewildering, but it starts to make sense once we go through this step by step. So above our ball origin, we have some empty space for about 60 units. Beyond this, we have the first obstacle's gap and then the first obstacle itself. Then the first obstacle gap once again. Here I've used a circle to illustrate what I'm doing, but you have to know that it could be another obstacle as well. This is just important for the illustration. The important thing here is that the obstacle distance will vary depending on the obstacle. So since we can figure out that using the calc distance function, we can calculate the star position very accurately. Right on top of this, we would have 120 units of empty space. Then we would have our second obstacle gap, followed by the second obstacle, and then the second obstacle gap once again. We've coded all of this in the obstacle sprite, and we've also specified the position of the first star as 60 plus the first obstacle's distance. For the next position, all we have to do is add 01, 120, and then 02. Since we're finding the obstacle gaps at each tick, what we can do is create the clone and immediately change y by 01. In the next tick, the star object distance will switch to 02, and then we can simply change y by 120 plus star object distance. After this, the clone will be created and we can change y by star object distance once again. This process would keep on continuing and we would pretty much have our stars accurately lined up at every single obstacle. Alright, now we can go into the obstacle sprite, get the goto coordinates block, and then drop it right into the star sprite. We can set up the final event in the star sprite, which will be a when I receive tick. Let's start by having an if else statement. In case the clone variable is set to yes, then it means that the object that the code is currently dealing with is a clone, and in this case we can use the goto coordinates function. In the x input, use 0 because after all the star will be right in the center of the stage. For the y input, you can use y minus scroll y. In the else statement, have an if then condition check. If the number of stars is less than the number of obstacles, then it means that there are more obstacles than stars and there are obstacles which do not have a star inside them. If this is the case, then we can simply use the create clone block. Okay, now it's finally time to program the calc distance block. What we're really trying to get into the star object distance variable is the change in obstacle clone y when we created the specific costume of the obstacle clone. So for instance, the star object distance in case of the big circle whose object number is 14 will be 90. So we can do some quick work and check 12 times what the obstacle is. If it's 11, set it to 65. If it is 12, set it to 70. If it's 13, set it to 80. If it's 14, set it to 90. If it's 15, set it to 125. If it's 16, set it to 120. If it's 17, set it to 90. If it's 18, set it to 90. If it's 19, set it to 90 as well. If it's 20, set it to 120. For 21, set it to 140, and for 22, set it to 140 as well. Okay, so that's going to be all the code that we need to put into the star sprite. We can now move on to the color switcher sprite. Here the code is going to be very similar, so we can drag and drop all of the stars code into the switcher. Let's quickly reorganize our code, and once we're done with this, we need to make a few changes. Obviously, the public variables which we've set for all sprites of the star are going to be different from the public variables of the switch. So what we need to do is create some variables in order to replace those star variables. The first variable that I will create will be called switch item number. The next one will be called number of switches. The third variable will be called current switch obstacle, and the fourth variable will be called switch object distance. These variables will just have to be put in place instead of the star variables. Uncheck all of those boxes to make sure that the variables are hidden, and now let's make the replacements one by one. First, change star item number to switch item number, then the number of stars to number of switches. Make those two changes once again, and then change current star obstacle to current switch obstacle. Add those changes for both the switch item numbers within the join. Change the input of the calc distance function to current switch obstacle, and then change y by the switch obstacle distance on both blocks. Since we are using the same code for the create clone function, we can save ourselves some time by dumping the code in the function and replacing it with the code from init. We just need to make two changes before that. First, rather than changing y by 60 plus the switch object distance, change it by 120 plus switch object distance multiplied by 2. We need to be very careful here because the 2 should only apply to switch object distance and not the 120. We can now duplicate the code and just remove the last change y in both of these cases. The rationale for this is as follows. As I explained for the star sprite, we'd initially have the origin followed by 60 units. On top of this, we will have the first obstacle's gap, O1, then the first obstacle, then O1 again, followed by a gap of 120 units. On top of this, we'd have the second obstacle gap, O2, then the second obstacle, then the second obstacle gap once again, then a gap of 120 units. The place where I would like to place the color switcher is in the middle of the additional gap. So it would be in these positions. We can now see that the location after the origin would be 60 plus O1 plus O1 plus 60. This simply simplifies to 120 plus 2 multiplied by O1. Beyond this, we can calculate the additional height to cover for the next switcher. That would be 60 plus O2 plus O2 plus 60. This would again simplify to 120 plus 2 multiplied by O2. Given that we store object distances within the switch object distance variable, the code will be set up this way. Alright, now we can move on to the when I receive tick. Just change number of stars to number of switches. The last thing left to do is the calc distance function. Within each of these if statements, we have to change star object distance to switch object distance. That's all we need to do for this video. In case your code was done correctly, the stars and the switches will show up once you test out the program. If you've enjoyed this video, please make sure you leave a like, and also don't forget to subscribe and turn on the notification bell. Thank you so much for watching, and I'll see you in the next video.